Okay guys, today what we're going to be talking about, to start with, is centripetal acceleration. So the unit we're moving on to next is called uniform circular motion. Now obviously uniform because it's the same. Circular equals circles, and motion. Hopefully all those things make sense. Now the reason we don't do non-uniform circular motion is because it's this way too confusing, way too challenging, and opens up a whole can of worms that just makes life way too difficult, especially for this year. Yeah, you just won't need it. Certainly not this year anyway. So what we're going to be talking about is uniform circular motion. Now uniform refers to the speed that the object is moving at in terms of a circle. So we can talk about moving around a circle with constant speed. So let's say it's got a speed of 5 meters per second. Now you notice I'm saying speed rather than velocity because, well, it's going around a circle, so its velocity is always changing. I'll hopefully illustrate this a little bit better in a sec. So that's as good as a circle I'm going to draw today. Here's our circle, and our projectile is moving in that direction. So it's moving, let's say, anti-clockwise. So our projectile is moving anti-clockwise. So at one point in time, it's here, and it's going to have a velocity of, at that exact instant, a velocity something like that. We call that VI. And at some other point in time, it's going to be about there, so just a tiny bit later, and at that point it's going to have a slightly different velocity. Its velocity is going to be more up in that direction. Okay, so we'll call that a VF. So VI is the initial, VF is the final. So as you can see, it's moving, it's going around this circle. So the velocity vector initially is this guy here, the velocity vector at the end is this guy here. You'll notice that the length of those arrows, they're the same. Let's just say they are. So those two arrows are the same length, which means it's going at the same speed. They're different directions because they're different velocities. They're two different points in the circle. So that means that it's going to have some sort of acceleration. Going back to last year, we figured that the acceleration is actually defined as the change in velocity over some unit time. So if we're going around in a circle, if we're turning a corner, if we are speeding up or slowing down, what we're actually doing is changing the velocity, therefore accelerating. Well, the other way to look at it is if you are moving in any direction and you are applying a force to change direction, speed up, slow down, you are applying a force, therefore you're accelerating, therefore you're changing your velocity over some unit time. So, change in V is final take initial. So what I'm going to do is I'm going to get my initial and my final and basically do this, final take initial. So in order to do this, I am going to do some weird kind of maths. V final, so we can't really take a vector, but what we can do is add a vector, and we're going to add the opposite of the initial one. So in this case here, what I'm going to do is pick up the blue one, put the arrow at the other end, and then put it next to this guy. So as well as I can draw it, that is negative VI. Okay, here's VI, here's its opposite, so it's negative VI. You can see they're parallel, near enough to the same length. They're both not really straight lines, but we'll just say that they are. So now I can, my overall change in velocity is that. So, which way is that heading? In this instance here, we got two things that are a reasonable chunk of time apart. If I was to bring this guy closer to here and do the exact same thing, what you would actually find is that this vector points more and more and more at the center of the circle. So in this case here, we have a towards the centre. And we call that centrifugal acceleration. It ensures, so if we have centrifugal acceleration, uniform centrifugal acceleration, we have a uniform AC, we have uniform centrifugal force. That can be friction, can be tension, so rock on a piece of string. You'll hear me talk about that a lot. It could be the banked corner on a NASCAR track or a bike velodrome, something like that. So we have this centrifugal force that causes centrifugal motion, and all it does is changes the direction that this particle is moving in. So you'll notice that I haven't sped it up, so the velocity is constantly that, uniform. It's always that, but it's always changing direction, which means that it's always turning. So if you've got something's motion that way, and the force is that way, so our velocity is there and the force applied is there, that and that are always at right angles to each other. Therefore it's never going to speed it up, never going to slow it down, but it will constantly accelerate it, which means it's going to go in a perfect circle. And that is exactly what happens when you spin a rock on a piece of string or do something similar. Okay,